We're looking at taking the derivatives of functions by using the definition of limits. So we're going to be doing the first principle here. For example, it says the derivative of f of x is equal to the limit of f of x plus h minus f of x over h, but as h tends to 0. In this case, what we're going to do here is we're going to take this function here and we're going to substitute wherever we have x, we're going to have x plus h. So then we're going to subtract f of x, which is 7 minus 6x, and all of this will be over h. We keep going. So what we have is 7 minus 6x minus 6h, and then we're going to distribute this inside, so we'll have negative 7, positive 6x, and all of this is over h. We're going to simplify. What we have here is negative 7 and positive 7 becomes 0. The negative 6x and the positive 6x becomes 0. Finally, we are left with negative 6h over h. But we could divide this, so the h cancels itself. So the derivative of f of x is equal to negative 6, and that's our answer. Let's take a look at the second problem. In the second problem here, we're finding the derivative of 5x squared minus x. So basically, the principle remains that dy dx, which is the derivative of that function, is equal to the limit of f of x plus h, and we're going to subtract the entire function f of x, and then we're going to divide this by h. But remember, h is tending to 0. So basically, we're going to have 5, open bracket, x plus h, and we're going to square that. Then we're going to have minus, in bracket, x plus h. And then we're going to take away the entire function, which is 5x squared minus x. All of this must be over h. Now let us work out these in parts. So I'm going to work out this part first. I'm going to square that. So I'm going to write back my 5. So when I square x plus h, I'm going to have x squared plus 2xh plus h squared. And then I could distribute these like this is minus x, this is minus h. I could clear these up too. I'm going to have minus 5x squared, and I'm going to have plus x. All of this is actually over h. I could take a second step. I'm going to distribute the 5 here. So I'm going to have positive 5x squared, and then I'm going to have 10xh plus 5h squared minus x minus h, and then minus 5x squared plus x. All of this is actually over h. At this time, I'm going to just cancel some stuff that I have to cancel. Okay? For example, 5x squared will cancel with a negative 5x squared. Positive x will cancel with a negative x. 10xh plus 5h squared minus h. And all of this is over h. We're going to divide everything by h. So basically, you would have 10xh if you divide that by h plus 5h squared, divide this by h, minus h, divide this by h. So this h cancel that, this cancel that, and this becomes negative 1. So what I'm left with is 10x plus 5h minus 1. What we want to keep in mind is that, remember, h is tending to 0. So technically, what I'm only left with is 10x minus 1. So that is our derivative right here, 10x minus 1.